Hello, Kathleen. You sent me an email, okay, about this questions number 20, right? This is test 7, section 3 in my book. Okay, so your question over here, yep, the problem cannot use number 5 and negative 2. Yeah, yours is correct, absolutely. Okay, we cannot use these two numbers because the denominator is 0, right? That's true. But I'm gonna try to solve this in three different ways. Okay, why we can use 5 or negative 2 mathematically or in physically. Okay, I'm gonna explain everything. First one, first method you can use with this comparison. Comparison is why this is correct. Okay, comparison is what compare, right? So numerator, take a look. 14 over x minus 5 x plus 2, right hand side 8 times x plus 2, okay? And the b times x minus 5 is a common denominator still, x minus 5, x plus 2, okay? But numerator must be equal to, so 14 equals, I'm going to write down over here, 14 equals ax plus bx, there is a plus bx, and plus 2a minus 5b. That's a constant term, okay? This is a constant. This is a constant terms. This is variable terms. Variable should be 0, okay? From here, we can get a two equation. A plus b equals 0, and 2a minus 5b equals 14, right? System of equations. So over here, 5a times 5 to eliminate variable b. Okay? 5a plus 5b equals 0. 2a minus 5b equals 14. Use the addition. Addition, there's 7a to 14. A equals 2. Okay? After that, you can find the value of b. Okay? B is, well, let me see. Over here, right? A is 2, b is negative 2. A is 2, b is negative 2. That's the solutions. But this method is good. Some other times we still can use like plug-in number reset. This is reset. Plug-in method. But this times on these questions here, okay, because we cannot use 5 and negative 2, you can use like some other two numbers, x equals 0 or x equals 1 over here. That's fine, you can do that because denominator always equals numerator. Take a look at numerator. 14 equals x equals 0, that is 2a, x equals 0 minus 5, okay, minus 5b. When x equals 1, 14 equals, when x equals 1, that is 3a, when x equals 1, negative 4b, okay? You can solve the two equations. You get the same number, a equals 2 and b equals negative 2. This is another plug-in number using undefined. When you have this one, 14 over 0 equals 14 over 0. Both are undefined, but still they are equivalent because numerator, same numbers. This is not working. 14 over 0, 20 over 0, they are not equivalent. But still, we can use this undefined. For examples, when x is negative 5, put this number negative 5 there, okay? 14 over 0 because that is undefined. Put this number 5 there, numerator should be equals 14 anyway, okay? Negative 5 over here are there. 5 plus 2 is 7a, a over 0, right? Still, this is undefined to be equivalent. This one should be 14 also, okay? This is mathematical rule over there, okay? Using undefined. So 7a equals 14, a equals 2. Or using negative 2 there, still negative 14 over 0. Negative 2 there, that is 0. Negative 2 minus 1, negative 7b, okay? So negative 7b over 0. That's still undefined. That's fine, okay? But this is the rule. It should be same number to be equivalent, even though both two terms are undefined. okay? To be equivalent, we just equivalent, okay? So b equals what's there? Negative 7, b equals 14, b equals negative 2, okay? Using this undefined mathematical rule, we can still use 5 and negative 2, okay? But actually, this one in the physical looks like this one. I'm going to take this is y equals 14 over x minus 5, x plus 2. Okay, this one is the graph looks like this because this is the graph looks like this. We have two vertical asymptote, x equals 5 over here, another one negative 2 over here. Graph will be y asymptote is 0, okay? So this one looks like this. I think that's true. This one and this one. The graph looks like this one. But when you multiply over here, x minus 5, x plus 2, okay? So 14 over x minus 5 and x plus 2. We're gonna multiply over a numerator, x minus 5, x plus 2. This is canceled out. Y equals now 14, okay? Horizontal. The graph will change. Graph will change this way. This is x and this is y. This one looks like horizontal. This is y equals 14. Okay. But still, x equals 5. There's a whole. This we set pod, P-O-D. When x equals negative 2, still there's a pod over here. I'm going to show you the graph over here, okay, using internet graph over here. So, the y course, this is original, okay, this is original. 14 over x minus 5 and x plus 2. This is the graph. As you can see, okay, very similar, right? We have two vertical asymptotes when x equals 5 over here, and another x equals negative 2, right? There is two asymptotes. That's true. And after you multiply over here, x minus 5 and x plus 2, x plus 2. This is the graph over here. Y equals 14, right? But we just got a 14 from original, okay? Originally here is still undefined. When x equals 5, there is undefined here. Undefined. There's a hole there, right? Yeah, this hole is called what? POD, point of discontinuity. And also over here, negative 2 is still undefined. That's true? Looks like this one, okay? We can use this undefined one. This is a physical meaning, okay? But left hand side, still we have this one. When you multiply x minus x plus 2, we got this one. This is, this is a y1, y2. So a times x plus 2 and plus b times x minus 5, because the denominator is going out. It should be looks like this one. It's going to be equal, right? Equivalent. So using this part, locations, where is the part? Part has at this coordinate, 5 and 14, there is a part, negative 2 and 14, another part over here. Okay? So you can use this one. Using the part, we can find the value of a. Where is the 5? When x is 5, y is 14. 14 equals when x is 5, it's 7 and 0, right? That must be equals. So 7 equals 14, a equals 2. Okay, this is a physical description, okay? A physical meaning there. There is physical. Okay, another one is when you can use also what this part, okay? When x is negative 2, y is 14. Negative 2 is y, this is going to 0, the other one is negative 7b, okay? From here we can find the b equals still negative 2, okay? Using the part, okay? But this is fine. You can use like the mathematical theorem, right? Okay, uh, undefined should be equivalent to, because one numerator is the same number, we can say they are equal. Undefined equal undefined. But this is not still undefined. This is a 14, 20 totally different. We can use this theorem, okay? So you can plug in number 5 or -2, okay? But you can see what the denominator is 0, but it doesn't matter. If the numerator is equal, still they are equivalent. You can use this mathematical rule, okay? That's why we can use these two numbers, okay? I hope you understand this one, okay? Thank you so much.